is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space, fields and forms, math and voids. It all sings with one voice. It's home. Boundaries set, foundations laid. Sound was heard, matter made. Solar systems from afar. Names and numbers for the stars, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space. It's the Lord's.
Well, hello, everybody. Welcome. It is I, Mark D'Antonio, and it is another night of Sky Tour livestream. Thank you for coming out. I see the chat room is full already. I'd like to welcome Daryl. Hey, Daryl, how's it going?
Hello, Mark. I'm good. You sound like you still got a scratchy voice.
Yeah, well, that's how it is, but we'll get through it, won't we?
Sure.
All right. Yeah, so, folks, we are looking at the moon at the moment, but that'll change. It's just about past first quarter, just about first quarter. It's just a few hours past first quarter.
I think the first quarter was last night.
Yeah, so we got a little bit of first quarter-ish moon here. And I want to welcome everybody already that's been in here. We got a lot of people that joined us already. Renee Cruz was number one. Tim F. is with us. Good to see you. And Michael Hedrick's with us. Nice to see you, Mike. And we are going to... Papa Tom's here, too. Hey, Papa Tom. we're going to look at a few really cool things tonight, a few nebulae that are nice. Daisy and Zoe Amethyst are with us. Hey, guys. Cindy Murphy's with us. The Desert Dweller. Hey, hey. How you doing from Mojave County? And then we have Calabos, which is our friend Mike from SpaceX. Hi, Mike. How are you? Great to see you. So let's get busy. Let's check things out. Now, you'll have to pardon my voice, but I'll clear it every now and then. But if we look at the moon, and we see it's just past the midpoint here, but that's okay. We're going to be taking our views elsewhere here momentarily, but I want to show you, this is our new field of view. See this? My cursor's outlining it. This is our new field of view. We used to have 4 full moons across and 3 full moons tall. Now we are actually closed in more, and we have many more pixels in that same amount of space by not quite double, but a lot more. So we get more detail per the square inch, so to speak, if you want to call it that. So it's not bad. Now, we will be moving. I'm going to bring up our planetarium, and we're going to go first to one of our favorite locations. And I'd like to show, let me just do this first.
Marianne is here.
Marianne. Hey, Marianne. How you doing? I want to say hi to Marianne Robb, who is in New Jersey right now. And I also want to say hello to Liz and Anthony in New Jersey. That's her brother and his wife. And the kids. We have some really cool little people that watch the show every now and then. And I think it's pretty cool. Marianne's showing them right now. And I think she's showing them our stream right now. I think it's we got TT, Victoria, and Zach, I believe. I imagine the youngest is probably in bed by now, but that's okay. All right, we're going to check out the Pleiades tonight. We're going to head over there now. And I've instructed the telescope to move, and as you can see right here, it is. There it goes. And what's really neat about this is we are controlling the telescope from literally 2,500 miles away. And here's the Pleiades right now. You can see it. And I will show that to you better because I was using a special exposure for the moon. I'm going to take it down now, bring it up to this. And now you'll see a little difference. Okay. All right, here we go. There we are. All right, so now I'm also going to increase our gain as well. We're going to go up to 200 gain, which is our standard gain that we tend to use. Here we are. Yep. And so now we'll move over a little bit. Move a little bit to the east.
Wow. Rutger Hauer's in the audience.
Okay. Roy Batty. Hey. Yeah, I saw him earlier, previous stream. Nice to see you.
I've seen things you people wouldn't believe.
That's right. I used to know that whole phrase, that whole thing, and it was all, some of it was ad-lib, which I thought was pretty cool.
Yeah.
Yep. Okay, so this is our current view of the Pleiades. Now this is what you'd see in a telescope. What you won't see in a telescope, however, is what I'm about to show you. I'm going to actually drop us down just a little bit. Just a tiny smidge. There we go. K7, how you doing? K7's with us. K7 edits. All right. So now let's use this for, first of all, let's just take a look. This star right here. All right, let me actually point these out a little bit more. Okay, this star right here is Alcyone. Okay, this star over here is that Atlas and Pleione? Pleione and Atlas, one of those two. Down here is Merope. Look, we got a little wind out there. Okay. And this star here is Maya. And Electra's over. I'm not sure. What star is this, Daryl? Do you remember?
No.
Okay. Why don't we go look?
Not offhand, I don't.
Okay. Yeah, we got some wind out there, though. Look at that.
Uh-oh.
Desert winds tonight. That's okay. You know what we'll do? Let's go and check out the stars themselves by looking in our planetarium. We'll zoom in here. And the ones I named I are correct. I just have to... Right. Okay, so... Okay, back out now. There we go. So that's Alcyone, Atlas, and Pleione.
Electra.
Like I said, so Merope. So that is Electra. Yeah, okay, I was right. And then we have Maya. Maya. Right there. There's Maya. And Tegeta up here. Seleno. This is Maya right here. Let me see.
Izabela's here.
Izabela, hey. All right, well, instead of looking at the planetarium view, which is a static view from however many months, years ago that it was made, let's take our own shot. All right, now we're guaranteed to get perfect shots because we're using a new filter system which makes this, that filters out the images if they're slightly blurry and will allow us to capture them. We're going to do a 15-second shot. No, 20-second shot. All right, we'll do 20 seconds. All right.
When we look at the Pleiades, the seven sisters,
Yep.
they're the seven daughters of Atlas, the guy who carried the weight of the world on his shoulders.
Right, which is this guy right here. All right, let's go into our live stack. And we're going to kill this image and bring in our live image right now.
Desert Dweller wants you to turn the music down just a tad.
I can do that. I was trying to save my voice without having to talk too much. I can do that. Okay, I think our first one was probably in the red. Yeah, we got the wind. I'll crank this up just a little bit more. We might not get it. I might just have to turn off the filter on the star diameter for now, just to see where it comes in. So this one will come in, and we'll get to see the nebula. Yeah, see though how it's got all that on there. Let me let's do this. Let's color correct first, and then let's process. So there you can see that swoop right there, right here. That's the Maya Nebula. This is Electra. This is Merope. And Merope has this beautiful nebula associated with it. And of course, the stars are elongated because we do have this wind out there right now. As soon as the sun sets in the desert and it starts to cool off, we get this cooling process, but it also causes these surface winds for a little while in the desert, and depending on the night, we either get them or we don't. Usually we don't.
Probably the last of the clouds blowing out too.
Yeah, we got those are just ending on us too. All right, let's see here.
They're running from you up to me in Colorado.
That's right. I told them to hurry up. All right. So this is in our parlance now, this would be a lousy picture of the Pleiades. All right. And we're going to try and clear this and see if this next one comes in better. I'm not using our full width half maximum. Yeah, see, that's still... yeah, the wind is still cranking. That's all right. We'll still salvage this.
Been pleasant here all week, 50s and 60s.
That's cool.
some clouds. We might actually get a white Christmas this year, which actually doesn't happen very often here.
Wow. You would think Colorado would.
Up in the high country, certainly.
Mhm.
Down here on the Front Range, it's a little different.
All right, let's see if we're going to get lucky with an exposure. Not yet. That's way out there. That's 13. Look at that. I mean, I could go all the way to 13 and beyond, but that's crazy. I don't want to do that. Because that'll be elongated. Yeah. We have winds that are causing this, so we may not be able to get a proper stack of the Pleiades. Remember, we stack everything. We take an image, align it with another image that we take, and then we just stack them and make an image sandwich. And that image sandwich brings out subtle detail. Okay, 12.6 is a little better. Let's see if we can reach that. We'll say 12.77. See if we can get an image to come in under that bar. Yeah, we did. Okay. So as you can see now, here the Merope Nebula, you can see just how beautiful it looks. It's got this really interesting swooping brushed look to it. And then the Merope Nebula's got this strange little curlicue right here and another one right there. Good, we got a second one. This is good. So I'm going to drop this down a little bit now. Drop it down to 12. As Daryl mentioned in the other stream, the Pleiades cluster is not just these 7 sisters that everybody knows. It's over 1,000 stars. And that's actually pretty amazing when you consider that there's this cluster. They're all moving together through space. And as this cluster moves through space, it's passing through dust that was littering the cosmos from countless supernovae explosions in the past. And this dust is sitting there and also orbiting the galaxy. And these stars are going through this dust. And as they do, they illuminate it and cause their blue light to be scattered by the dust. The tiny dust particles scatter high frequencies, which is the blue end of the spectrum, very efficiently. And so we'll see lots of scattered light coming to us from these dust clouds in the galaxy, especially when there's hot blue stars nearby.
You can see it naked eye, actually. If you're in a fairly dark sky and you know the Pleiades are up, just look up in the sky, but just park the Pleiades like in the corner of your eye in averted vision. And you're not just seeing the light of the 7 stars, you're seeing all 1,000 of them, plus the reflected light in the nebulosity. It becomes quite a hazy patch up in the sky to the naked eye, about as big as a postage stamp at arm's length.
Yeah. Yeah. These halos are from the optical system we use, okay? We're using a F2 system, which means it's very fast photographically, so bright stars will tend to make a halo. It's an artifact of the optics. We get rid of those when we process them, in final. But these images here that we take, these are images that you get to take. When we save these, they go out of the observatory 2,500 miles away, and they go into our server, which I think is somewhere near Cincinnati or Falls Church, Virginia. I'm not sure. But they go to our server, and they reside there for you to grab. And how do you grab them? You go to that link up at the top. See that right there? SkyTourLive.org. That's our portal into all things SkyTour Livestream. So you can go there to get our pictures. You can go there to see our pictures. You can go there to explore, find out more about us. You can go there to also join our Patreon. We need support to keep doing this thing, and that's what we're doing, is trying to get that. So please consider becoming a Patreon member, and for a small monthly fee, you can enjoy this and so much more. And the higher tiers, you get a lot of benefits too. You get the fully finished processed images from us, and access to those directories. You can download them as many times as you want. So it's pretty cool. But please do consider that. And you can find that at skytourlive.org. In the upper right, you can see join our Patreon. So head on off and try it. I think I have a 3, 5, 10, 25, 50, 100, 200 tier, something like that. Believe it or not, we have upper tier members. All right, so this is cool. Now see, if you look right here, you'll see that we have 12 images that were rejected and 3 that were taken. What does that mean? That means that those 3 original ones that we saw, if we come over to this box, see, we caught them, and they're right here, these 3. All these would have made blurry star images, but we reject those. So we only got the best star images. So that's pretty cool. We like doing that. And so when the wind dies down, we'll be able to capture better ones again. But we're not doing bad already. This is pretty good. The Pleiades is bright enough. Look at this cloud. Look at how extensive this cloud is. That's really cool.
Mark, Marianne has a question of you.
Yeah. Oh, your nephew Mark was asking how many galaxies there are. Well, actually, the answer is that we don't really know for sure, but it's more than 1 trillion and perhaps as high as 2 trillion, which is, a trillion is 1,000 billion. Okay, so it just goes on and on. We tend to think there's a lot of them out there. Izabela, thank you. I did send a community tab message today suggesting we'd go live. I think I said 9 p.m. and we ended up going at 10. Sorry. But unfortunately, the notifications now are at the time the stream starts. And the reason for that is because we're streaming to Rumble, Twitch, Trovo, Facebook, YouTube, all in one shot, and soon we're going to be streaming to Instagram as well. And when you do that, what it does is it takes away your ability to create the stream first and let people see that it's coming, unfortunately, because it's more than one platform, and that's a problem. So there you go. That's why it's happening. Okay. Well, this is going to be the limit on what we can do for the Pleiades because it has the winds are not cooperating out there. So we only got 3 out of 23 shots so far, but that's okay. And what we can do is just do a little last process. Drive down the color of the background, do a color correction. There we go. And we'll save it. Okay. And we'll save it exactly as seen. So it saves it first. When I say save it, it saves it as a FITS file. That's an astronomical file format. If you don't know that, you don't care, you don't need to. But if you just want the picture, well, then I save it exactly as seen. Then you get the ping file. So you can just double click and boom, up it comes. So, okay. So let's get out of this. And let's go back to our low light view. And move on to the next. As you can see, the stars are actually getting blown around quite a lot. Yep. Calabos is mentioning our telescope giveaway that he's doing with us. And we are going to be hosting the telescope giveaway. We're still working out the details, and we're thinking we may be giving away binoculars and low light systems as well. But that's something we all have to discuss and figure out how we're going to do it. So
Galabos wants to do it right now.
he must do it now. Well,
Yep.
I wish we had a way to get people. Oh no, one giving away one tonight for Christmas. Okay, well, oh boy, I wish I knew that, Mike. We would come up with a really cool idea for how people could put in their names. All right, so you know what? Let's think about that. Do you want to give one away, Mike? You want to do that tonight? All right, let me see something here. I see we have Cosmic Rays here, Marianne's here, Marco, Papa Tom, Renee Cruz, Vince Giglio, Michael Hedrick, and Renee Cruz, and several other people. Boy, I'd really like to. Daisy and Zoe Amethyst. So let me try something here. I'm gonna take. I have a list of everybody's name. I'm gonna put it in a file, and I'm gonna do a random drawing. What do you think? Should I do a random drawing, folks, for a telescope tonight? You told me. What do you think? Michael Galia's with us. Oh, Michael Galia says I'd like to. Wait, he's Callum's got some ideas here. Okay. Oh, I was hoping in this chat. Okay. Can we think of a number between 1 and 1,000? Well, you can do it that way. You could do it that way. All right, Calabos, you work it out. You think it through, and I will. I'll follow your lead. Michael Hedrick says change the title. I already did. The title is changed to what I wanted it to be.
Marianne has another question.
Okay. Okay, the question is, Liz from New Jersey asks, are all of the stars surrounding the Pleiades planets or what? And do you know about how old they are? Well, they're young hot stars. They're B-type stars. They're not that old because B-type stars burn furiously. And because they're B-type stars, that means they're hot, they're young, and that means that planets are likely unable to form around these stars because they have very, very powerful stellar winds. So most likely in the primary B stars that we see, which are these main stars and some of these others, there are probably not going to be any planets around these, okay? But in some of the other stars within the Pleiades, and there's like 1,000, there may be some planets that may have formed in some of the lesser windy stars, stellar windy stars that don't have as much ultraviolet radiation, but they still may very well have a problem with being sterilized by the ultraviolet radiation coming in from these other stars, because it does go off quite a distance. It goes quite a distance away. Christine Anderson, otherwise known as Chris Anderson, is saying, "Giving away a telescope. I'm right here." Yeah, okay.
Marianne has another question for you.
You know, I bet she does. Look at our winds, guys. We're letting the winds calm down, so we're good. These guys are so excited that you're on. Ha ha ha. Yeah, as I'm sure they do. Okay. You did not have another question? Oh, wait. Can you see black holes with this telescope? By their very nature, black holes are dark. So we're unable to see black holes. We could technically see what black holes do to the surrounding space when we look at the Andromeda Galaxy or other galaxies out there. Many times we're looking at these galaxies which are being originally seeded by and held together by these supermassive black holes in their cores. So it's possible we can see by looking at these spiral arms and looking at galaxies with these stars going around that the major sized black hole in the center is the reason it's all happening. So that's a strong possibility. Calibos, can you share with me in a private message the number for tonight?
Marianne's, oh, no, you got that?
The black hole question?
Yeah.
Yeah, here's the other thing. To have a valid entry in the telescope contest, you have to be subscribed to this channel. So if you're not a subscribed member, please subscribe, and then if you give your number guess in the chat, we'll know who was first to say the number that was lowest or closest, and then we'll be able to verify that you're a member of SkyTour, and then if so, you win a telescope for Christmas, courtesy of our friends Michael and Tiffany. Calibos has been with us for a number of years now, and I met him at Contact in the Desert last year along with his amazing girlfriend Tiffany, and they're very, very good people. They want to see astronomy, as I do, just spread out to the masses. We're using a rather unique way of doing it. We show you the universe live in real time, which is what we're doing. So that's what they want to do as well. And they want to do it through giving away telescopes, which I think is unbelievable. Okay, in the chat. Okay, thank you, Michael. Michael sent me the number in our private chat. Gotcha, Michael. Thank you. I got it.
Count me out, too.
Huh?
Count me out, too. I already have more telescopes I know what to do with.
No problem. Okay, while we're waiting and while people are making their guesses, we're going to go back through the chat and make sure we find whoever's closest to this magic number. And if I read Michael correctly, that would become our winner. And you don't have to be, it doesn't have to be, a without going over thing. It can be above or below. but within a certain range. Whoever's closest. Okay. Thank you, Michael Hedrick. Michael Hedrick, he does a fine job for us. He's fantastic. Always helping us out. All right, so let's check something out now that I would like to look at. I know that you'll like to see it too. What do we got on that?
Rhymes with Crab Nebula.
Huh?
Said it rhymes with the Crab Nebula.
You funny. Yeah. There is a lobster nebula too. This is going to be kind of close, but I think we're just going to clear the building with it. Yeah, there it is. Okay. Remember I talked about the dark dust that the Pleiades are traveling through, and that their blue starlight is being scattered by the dust. Well, where's that dust come from? That dust comes from things like this right here on the screen. That right there is the Crab Nebula. And what I'm going to do is I'm going to show you the Crab Nebula. And I'm going to illustrate for you how amazing... Oh, we got a cloud. Look at that. Oh, I saw there was a patch coming through, but I don't think this is going to stay. So we'll get this to work.
That reminds me.
Yeah.
Did you say you were thinking about building an all-sky camera?
I'm gonna, yes.
Okay, that's interesting. YouTube has been offering me a lot of videos lately on, I guess it's a thing now, people are building their own dark sky cameras.
Well, the all-sky cams are actually quite easy to build. I'm going to use, for those out there that are familiar, it's going to be a Raspberry Pi-based system. And I'm using an Arduino-based system to run the observatory. But I'm going to use Raspberry Pi for the all-sky. And I'm going to get another ZWO camera. It's going to be a color camera. And I'm going to use that to actually do the all-sky views. Speaking of all-sky views, let's go see if we can get an acquisition here to see if we can get an idea what the clouds are doing. This is our current all-sky camera we got running. When the telescope's running, sometimes it okay, well, there you go. That's what we got going right now. Let me go check and see where that is and whether it's going to last for a long time.
I was wondering about that. I had been, Bill got himself a new camera lens, I guess he's happy with it. And
yeah,
he was talking about fisheye lenses and all sorts of things.
Yep.
I would wonder if you had a really high quality all sky camera, if you couldn't do like you do with your present setup. You could pick an area and zoom in on it.
Yeah, actually, you'd be able to.
That'd be cool.
Okay. All right, this patch is going to pass, so we're going to let it pass. So we'll let this, we're going to minimize this. As you can see, the Crab Nebula is now the Cloud Nebula. Hey, DPFX, how you doing? We're going to let this go a little longer. Francis Palmer, how are you? Marianne, he basically said, for this first contest, this first giveaway, pick a number between 1 and 1,000 and put it in the chat. Whoever's closest, whether they're above it or below it, will be the winner of the beautiful brand new telescope. Okay, so we are looking at clouds right now, guys, but just give it a few minutes.
I hope somebody's writing down the numbers.
Well, they're preserved in the chat.
Well,
But
yeah.
yes, they are being written down. And Cosmic Ray built an all sky cam too. Yeah,
I see
Raspberry
that.
Pi 4. That's what I'm using. We're on hold for a little bit while we wait for the clouds to pass.
Pick a number, Marianne.
She is not able to participate in the contest.
Oh, okay.
There's a private chat between Calabos, Marianne, Tiffany, and myself, and we're discussing all kinds of things with SkyTour Livestream, and among them is this contest.
That's
So
it.
she is disallowed from participating in this particular contest.
Makes sense.
Yeah. Cosmic Ray, as far as the camera getting cooked in the sunlight, did you add ventilation to the camera, to the housing? Because you have your dome, but underneath it, as long as you add ventilation, you can make it pass through the camera. Oh, look at, there's the Crab Nebula. Appearing from behind the clouds, guys. Look at that. I'm just going to do a 12-second shot just to see if we can capture it. Oh, maybe not. This music is perfect for this. We're gonna get this thing, get this thing, get this thing. Come on, come on. Isn't it amazing how the stars just appear and the clouds block us, and then boom, there's just this faint thing thousands of light years away hanging out there. It is windy, as you can see, even it was bouncing around. See how the stars get elongated, then they get round again. That's from the wind blowing the whole telescope around. Yeah, okay, well, let's wait it out a little longer. Okay. The Orion Nebula is at an altitude now of 27 degrees, and we need to be a lot higher. Yeah, as long as you subscribe to SkyTour Livestream, you can put in a guess and win a free telescope right here tonight. Merry Christmas, Happy Holidays. And that's from Calibos, our friend at SpaceX. And it's a beautiful little telescope. And it will get you excited to go out there and look at stuff in the night sky. And we'll be available to help you with it as well, if you have questions about it. We'll send everybody to you, Daryl. I know. Okay, looks like we're getting some clarity now. We have a shot now. We're going for the 12-second shot here. And we'll get rid of this past shot we did of the Pleiades. And in comes hopefully our first shot. And it came in good. I have the filter on, but it looks like it. Wow, look at that. Really bad shot. I have to change this. Let's see if this does any better. Okay, look, we're getting some good shots. So I'm going to clear this now, and maybe we'll get a good image. I'm going to call it the Crab Nebula. Okay, it's still not good enough. We'll go down. Yeah, see the wind's popping in. When the wind stopped, we actually got a very good shot here. We're going to clear this again. Yeah, now it's up in the 10s. We know that's not going to be good. Hello, Trisha Ferreira. How are you? Genghis, how you doing, man? Calibos says something very important. He says, just so everybody knows, this is the first of many telescope giveaways. So if you don't win this evening, you'll have more chances in the future. And we're looking at more than just telescopes, too. We have ideas about some binoculars we'd like to give away, and some low light. There's a good one. And some low light optics as well. You know, you hold them up to your eye, night vision. In particular, we're thinking of the Psionics Aurora Sport that we might be giving away as well. And I'll be talking to Michael about that as well. I have an Aurora Sport, and it's a full-color, night vision camera. This is nice. Look at that, Daryl.
Mm-hmm.
So let's.
Ed Ting just recently posted another good starter telescope just a few days ago.
Yeah, what did he do?
I don't know what it is offhand. If you go look at Ed Ting's page on YouTube, I'm sure you'll find it just a couple of days ago.
Okay, we got 4 frames that came in and 4 that were ignored. So we're right where we need to be. We're getting some in and some that are over. But if we keep this full width half maximum, which I'll explain in a second, number lower, then we will be able to get perfect images even if it's windy out, because we'll only accept images that are just happen to be good shots. Now the full width half maximum, if you look at a light image, a star image on a photo, it could look like a curve, goes up, has a little bump over the top and then down. So kind of like a lumpy like I'm drawing right here, like a little shape like that. Now, if you go halfway up that curve, you draw a line across, that's the half maximum width. And you want that to be really small for a star image. And if you make it nice and small for a star image, it means the star image is going to be round on your final image. So by setting this value here, arbitrarily up and down, we can set that value to either be slightly bloated or very, very, very precise. The more precise you want it, the fewer frames you're going to get. Okay, and we got 4 so far here. And I don't know if we're going to get any more, but we're going to try and hang out and see. But I want to show you. So this is the Crab Nebula. Notice the filaments in here. These filamentary structures that you see in here are absolutely amazing. Alicia Vieras is here with us. How did Darlene do with her cheer? I think Darlene's probably asleep.
Uh-oh.
Yeah, she had her tonsils taken out. I saw the images on Facebook. I didn't get a chance to comment. I'm sure it's been rough. Kids wake up with a sore throat. It really is painful. Coughing hurts. Inhaling hurts. Dean Bostador, how you doing? Darlene's team got first in San Antonio and fifth in Houston. 3 more competitions to go. Fantastic. I met this 10-year-old girl down in, was it Roswell, Alicia? And she was really smart. So I actually gave her one of my books, The Populated Universe. And I know she started reading it. I don't know if she's going to be able to finish it, but she started reading it. And I was very proud to see her doing that. And so it gives her a little bit of a foundation and in life in the universe. And, we all have those questions, right? Is there life in the universe? We don't know. But we do know one thing, and that is that objects like this one, the Crab Nebula, are the reasons that we do have life in the universe, because these large stars that do explode like this one did to create this object here, these large stars are blowing their guts out into the universe and spreading everything they create out into the universe. And what is it they create? Well, they create the elements in our periodic table. The hydrogens, the carbon, the oxygen, the phosphorus, the potassium, the magnesium, the calcium. It's creating these elements because the elements have successively higher numbers of protons in their nuclei, and that makes them a new element. Hydrogen has 1 proton, helium has 2, and it's the second element in the periodic table. Then you have lithium, beryllium, you have carbon, nitrogen, oxygen. So you've got, it goes on all the way up to 118. So some of those are created in the lab, some of those are created in stars. But they're very plentiful, and it all derives originally from a supernova, or from a star like our sun that expands into a red giant and ends up with an outer atmosphere enriched with molecules because it's so far away from the center that they can happen out there, and it's just incredible. And so when you look at what the element count is in the universe, hydrogen is the most abundant. It was made originally in the Big Bang, and it's the easiest element to make. 1 proton, 1 electron. Okay? Helium is next in abundance. And then the third most abundant element in the universe is not the next element in the periodic table. It's actually oxygen. The air that you breathe, the atom, oxygen, a single atom, not 2 atoms, which is what we breathe, O2. But the single atom oxygen is the third most abundant element in the entire universe. And so the fourth most abundant element is that from which you are made most of, and that's carbon. You have an awful lot of carbon. And carbon's a very interesting atom, because if you look at the way carbon is laid out in its nucleus, okay, it has 4 electrons on the outside, okay, what's called the valence shell, and the outer shell on carbon is 4 electrons, and those can each bond with something different. And that gives carbon the unique ability amongst all the elements in the periodic table to bond with more things, make more bonds than any other element in the periodic table. And those bonds can be broken, and those bonds can be forged in an easy manner. So this means that carbon is flexible. This means that carbon is plentiful. And this means that carbon is likely the basis of life throughout most of the universe. Now, I say most of the universe because there might be some other strange forms of life that utilize silicon, but I don't believe so. The next most likely element that could forge life and support life is in the column below carbon. And what's below carbon is silicon, Si, silicon. And the silicon atom tends to make robust bonds. So it tends to like crystals and make crystalline structures. I've said this many times. Sand is silicon dioxide. It's silicon with 2 oxygen atoms married to it. So you have a silicon atom in the middle and 2 smaller oxygen atoms. Okay? And this leads to an interesting thing that you can tell all your friends, and that's when you go to the beach, you can say, hey, you're walking on sand, right? And they say, yes. Well, you know you're walking on mostly gas? And they go, huh? Yeah. Silicon atoms and then 2 oxygen atoms. So 2/3 of the sand you're walking on by atomic count is gas. So obviously you say, well, why is it a solid? It's a solid because the silicon atom is that much bigger. But you don't have to tell them that.
I have a question.
Yeah.
I suppose this comes from recent Webb telescope results, early universe and all that. I've seen speculation recently that early on in the universe, elements were being produced with atomic numbers as high as over 200, like 260. And, of course, as you said earlier, I think our periodic table now only goes up to 118, and anything above 92 is artificial. What's your opinion of all that?
Well, okay, first of all, you can make elements higher than 118, but their lifetime, their half-life, is very, very fast. So they very quickly reduce to something else.
Right.
When stars are undergoing nucleosynthesis, they make other elements beyond what they may normally make, but they also quickly reduce. For instance, there's not a lot of lithium in the universe, right? But that's because lithium decays very quickly to something else. And nitrogen also does that as well. There's various isotopes of iron that do that. An isotope is just a different type of the same element. It's an element that has 1 or more neutrons in its nucleus other than just protons. And neutrons don't have any charge associated with them. And so elements that are very heavy could have been forged in the early universe, but they would decay very quickly to something else. And it's all about stability, right? If you have stable elements, then you have something that you can build on. You can't build on an isotope that lives 4 nanoseconds. You know what I mean? So you can have the more massive isotopes, but they many times quickly decay to other things. And
Well, I
sometimes,
know
go
if, we posit all these wonderful things that Webb is supposedly showing us about the early universe, if somehow their conditions could have been so different that, if heavier elements could have sustained, have longer half-lives. I know there's talk in the chemical synthesis now, elemental synthesis, that the so-called island of stability, they think may be ahead of us somewhere. That if, what would such super heavy elements have been like in a stable early universe?
Yeah, the elements themselves though wouldn't be stable. That's the thing. Yeah, keep in mind what holds elements together. Okay, it's a strong nuclear force, and so the strong nuclear force is the strongest force in the universe, but it only acts on a very, very short distance. So as you grow a nuclear core, as you grow a nucleus, and you put more and more protons in there, those protons are held together by this strong nuclear force. Now remember, protons are positively charged. They want to fly away from each other. So what actually holds them together? That's the thing that's interesting. Now, it really takes looking at what the proton's actually made of to see this. And a proton's actually made of 3 other particles called quarks. Okay? Now, for a proton, you have 2 up quarks and 1 down quark. And based on how the charges work out, you get a +1 charge on the proton. Okay? And I can go through that with you if you need to. You being everybody. And a neutron is 2 down and 1 up quarks, so that you actually have a net charge of 0. But the protons are positively charged, so what's holding them together? Well, those quarks that make up the protons, they're held together. All right, those quarks, there's 3 quarks that make up a proton, and they're held together by what's called a gluon, a particle gluon. It kind of makes sense, right? The gluon particle is a fascinating particle because it's holding those quarks together to make the proton, but it reaches out a little further than the proton. And so what's actually holding this proton is what's called a residual force, a leftover force, so to speak, from the gluon holding the quarks together. And it reaches out, and every proton has that same thing going on. But you get a nucleus of a certain size, you can only get up to about 118 so far. And beyond that, the nucleus can't hold together, can't hold 120 protons. It quickly decays back to 118 or some other element, because that strong force isn't enough to hold that nucleus together. So that's part of what's going on here, So when we say, yeah, there might be some other momentary particles that may have existed, that's true. And they may have actually had a higher mass, that's true. But what's also true is that they probably would have very quickly decayed into something else that could be managed by the quantum forces that are holding the atoms together. That's where I'm going with this. So I don't know if that makes the most sense, but it is what our universe is made of.
Well, I guess I was wondering more the idea of the island of stability. If conditions in the early universe might have provided a so-called island of stability to such super heavy elements.
Yeah. But
that's all what-if stuff, though.
Yeah, that's true, but still, it's all good questions. The problem I have, though, with it is not the question itself, but the the premise. Did our universe ever support, or was there ever a structure in place that could actually support a very large atomic nucleus? Keep in mind that the early universe really only had hydrogen in it and some helium, some boron, lithium, beryllium. Those were the early elements, the simplest elements. And it was nucleosynthesis that and those fires in the nuclear furnace that actually created these heavier elements. So what does it mean when we say, could there be an element that has a atomic count of 220? If there was, it would have to have been forged in some really obscene catastrophe, like a hypernova or something like that, that may have forged something momentarily, but it then would have quickly broken back down and decayed back to something else. Now, the Large Hadron Collider, LHC, over at CERN, is trying to find some of these strange particles, some of these potential particles that may exist, theoretical or otherwise. Among them, the Kaluza-Klein graviton, which I've talked about as a potential fifth-dimensional travel capability. They're trying to find it with the Atlas accelerator over there. So, as you say, it's all a bunch of what-ifs, but still, think about it. It's an amazing amount of thought that we're coming up with to try and answer the questions, the riddles of the universe. And among them are the riddles of what does things like this make? What does this object spew out into interstellar space? And what is it that we can learn from what it's throwing out there? How many elements are being made? How many elements are being destroyed? And how many elements are being made that are potentially elements we haven't ever seen before? Do they come and go? So far we think maybe yes. But it's all very possible. So I don't doubt it, Daryl. Okay, we managed to get 30 exposures out of this, so we're going to zoom in and check it out and see. Yeah, some of the early exposures were just a little bit oblate, so we didn't really get the pulsar too well, but it's right there. So we can, whenever the moon's out, it throws the color rendering off a little bit. We have to kind of manually correct for the color.
Still blows my mind. We said this before, but when you see the neutron star there in the center,
that's right.
As you said, that's about the size of Manhattan Island.
Yeah, right.
And
there.
yet we can see it thousands of light years away.
Yep. Isn't that incredible? That's incredible. Okay, we'll save this as it is because we're not going to do any better than this. And besides, it's already it's looking as best as we could probably get it. That right there is that's that neutron star Daryl was telling you about. It actually is a stellar remnant, like Daryl said, the size of Manhattan Island, and it's spinning about 33 times per second. Imagine a big giant sphere, the diameter of Manhattan Island, Manhattan Island is long, and spinning 33 times per second. Can you imagine that giant, massive thing spinning over your head? That's incredible. We're going to drop this down. And then we'll back out. There we go. This has been tracked for over 100 years, and we can actually see in the photo imagery, we can actually see it expanding. It's been moving like outward. We can actually watch it expand out. And the time will come where the pulsars, ultraviolet energy and X-rays and very, very high energy that's giving off will no longer be able to ionize this cloud of gas and dust that's being pushed away from the star. It'll ionize the gas anyway. And the dust is being forced away as well. Okay, we'll save this here. Don't forget this contest for a telescope tonight, guys. A number between 1,000 and 1 in 1,000. Whoever's closest wins a telescope. How about that? Cosmic Ray wonders, you know, when the Chinese in 1054 AD saw this thing for the first time, to them it looked like a star in the sky that just appeared. It's like, whoa, what's that new bright thing in the sky? You know, another star. And it was really probably an amazing sight. Similar historical impact if Betelgeuse went supernova. When Betelgeuse goes supernova, we'll see that too, and it'll be bright in our daytime sky as well. And the only thing that makes us something visible in the daytime sky is going to be its luminosity or its intrinsic brightness. And we see the moon because it's big in angular diameter. But if it's not big in angular diameter, it's going to be small. It's going to be very bright. And if it's very bright, then we should be able to see it. And we'll see Betelgeuse, a star in our daytime sky. That's going to be an amazing time in history, I can tell you that. Okay, let's hop out of here. And let's go back to our low light system. Okay. All right. And we'll come back and get us back to just... Yeah, we're getting a lot of wind, so I'm hoping we can keep going tonight here. I would like to go see one other thing right now. The sky is really pretty. I hope we can grab it tonight. We're going to go check out a stellar nursery. It's a stellar nursery that I think you'll really like. Can't remember if it's this one or if it's this one. I think it's this one. I'll just do a 15-second shot. Well, we're going to have wind anyway. I'll do a 15-second shot without trying to stack it, just to catch it. Yeah, okay, it's right here. All right, so I shall now get us there. Excusez-moi. All right. All right, here we go. All right, so I'm going to pull this down. This is called the Flaming Star Nebula. This is a stellar nursery region here. There's a lot of dust in here, and there's a lot of hydrogen gas that's being ionized. And it really is beautiful looking. I have to show you.
Bonnie's here. Hi, Bonnie.
Anahata 77. Hi, Bonnie.
Bonnie, pick a number from 1 to 1,000.
Bonnie, we're actually in the middle of an active telescope contest. If you can pick a number between 0 and 1,000, you get one guess. And if you're closest, whether high or low, doesn't matter, you will win a telescope tonight. Mira Krasinski, how are you? Do the same. Calibos is running the contest, and we're hosting the contest for him. All right, we're going to try and I see your stars have to. We're going to try a 20-second exposure. I don't know if it's going to work, but that's because the telescope is being blown around by the wind.
Did you save the crab?
I did.
Okay.
Okay,
I want to rename this.
Yeah, I'm going to. Okay. Let's see where we're looking here. 7.88. Okay, we can do that. Let's go up to just above that. We'll say 8.15. Let's see if that gives us ours. Thank you for putting up the link. Hey, Mr. Django,
Sure.
how you doing? All right, let's try again here. Oh, there we go. We got our first one. There's the Flaming Star Nebula, and hopefully we'll get some good ones in. As we get more in here, you'll see a very interesting pattern arising. You're going to see some amazing red nebula that looks like fire, which is why it's called a flaming star. But at the same time, you're going to see other things showing up as well. And let's hope that we are allowed to see them here with this particular night. Okay. We're going to approach the peak here. Get maximum good contrast. So far, we're still only one image.
Ricola.
I know. In fact, while we're waiting here, you guys mind? I'm going to go grab myself a water. I'll be right back. I shall return.
Hurry back.
I will be.
What's Irish, rugged, and stays out all night long? What's Irish, rugged, and stays out all night long?
There we go.
Patio furniture.
Okay. Still waiting to get a second image here. Looks like we're getting all over the map here. Yeah, the wind's blowing us around pretty bad out there, guys.
Yeah.
Hey, Judy M, how are you?
Sorry,
Judy,
I told a joke while you were gone.
Oh, that's all right.
The only clean joke I know.
Uh-huh. Universe inspires me all the time, you know that? Yeah, we fight via our atmosphere, trying to peek through our atmosphere and everything. But it's just awe-inspiring. It really is. See this? We play with this contrast. Look at these bright ribbons and filaments up here. It gets much better than this. So, if you look now, you can start to see there are some interesting subtle blues showing up in here. Subtle blue colors. See that? You're going to see more of them. If we can actually get our, yeah, we're way up in the 9s and 10s and way up there. Ah, we got one. All it takes is one more. Now you'll notice something immediately changes. Now we see more blue down here. Here. Down here. Around there. Look at that. Very nice.
Biggest blue I see is to the lower left of that bright star near center.
Right here.
Yes.
Yep. That's right. So it's good. We got see what our technique is, though, guys. We're actually using only those star images that aren't being moved by the wind. So we're always guaranteed a good shot. It just takes longer for us to get it. I don't want crappy shots. Nobody does. So let's see if we're gonna grab another good one here. Nope. All right, it's starting to come down. Maybe the next one will be below it again. 9.49. No. Okay. What we can do, we can go to 8.31. Well, let's see. Okay, folks, if you haven't already put your number in, keep in mind that we see the whole chat. It doesn't go away. We'll be able to find the person closest to 1,000. And whoever is closest to 1,000, that's tonight's contest, you will win a telescope tonight. Courtesy of Calabos, hosted by SkyTour Livestream here. All right, there's another good one. Calabos, Michael, my friend from SpaceX, and his amazing girlfriend Tiffany are the ones that are organizing the contest, and we are facilitating it. Now look at this. Look at this. We have 4 frames taken in, and you can see this beautiful blue here. Look at that right there. You got this beautiful blue. This is very rich in blue. We're going to zoom in a little bit now that we can. Look at that. That's pretty nice, though. This is a really nice area.
I was doing something. Let me look. Yes, it is.
Okay. We just got 5 frames now. That's good.
And the blue's coming out more in that lower part, too.
Yes, it is. There. Now we see it here and here.
Yep.
And a nice subtlety here. This is always intriguing me. This little dark tendril here. That's actually a dark nebula right there. you know.
What's making the brighter red blaze in that one area above the bright star?
That's a good question. Now, it could be a couple of things. It could be density of hydrogen in the region. A higher density of hydrogen means that you'll have more atoms per cubic centimeter that are ionized, and thus you might see a brighter filament. So if it's a denser patch of hydrogen, that could be from shock wave of an outward moving shock wave from a supernova that's a distant supernova, or from other processes going on nearby. But you're right. So that's more dense than typical. And we can zoom in a little more, actually. Now,
maybe it's just heavier gas there, thicker gas. I assume
yeah, the more density
being excited by the bright star below.
It could be, but there's no reason it can't be from, any of these smaller stars in the neighborhood. We don't even know, because if they're hot, they could be ionizing. I mean, this like that star right there. We don't know for sure, but that star could be doing it. It could be this star right there. Again, it's a 3D universe. Hard to know. If this star is the one doing it, let's actually go into Stellarium. I want to take a look at that star. First of all, going over here, I want to look at the star. Okay, the star we're looking at is this guy right here. And this is a O9.5. So that means that this star is an O-type star. It's among the hottest in the universe. Okay, so it's going to definitely have an ionization potential that goes, many light years away from it. So that could be the one, Daryl. It's almost a B0. It's an O9.5. So you could be right. This could be the star right here that's doing it. As long as this is not too far behind or in front of it.
Yeah.
Okay, we got an eighth photo came in. See that we took we've taken 32 photos, and only 8 of them were taken and used to make this stack. Otherwise, this would have been just all like dashes. The stars would have been crappy. So I like our filter. This is a great filter. Let's see how it wants to process. Yeah, look at this. Look at that beautiful blue right there. I'm going to zoom in more. All right, and let it just look at that. Now you can see all this subtlety in here. There's a beautiful knot of dark nebulous detail right there, dark nebula. Okay. Reflection nebula in here, which is the scattered light from probably this star or maybe that star. Interesting how this all works. Beautiful blue here. Flaming star. That's really pretty. Let's actually go in even further. Here's the O-type star right here. I can see that our stars are a little bit of dashies because it's not quite perfect. Let's see all the blue. Look at all that blue. That's what happens.
Yeah, the O-type star is AE Auriga Uh,
That's exciting, the nebula.
they call it a runaway star.
Because of its proper motion?
I don't know yet. I haven't got that far.
Because my thesis in astronomy was runaway B stars, and there were high proper motion stars that are actually running out of the galaxy, heading out of the galaxy at high speed. I found like a bunch of them. That's really cool. All right, look at that. That's nice. So yeah, we got 12 frames here. Okay, we'll save them. All right.
Mark, would you excuse me a moment, please?
Sure thing. Hello, JSCO77. How you doing? Okay, folks, keep trying. Keep trying to put in a number between 1 and 1,000. We have a number of entries so far. Closest person to our magical number, which we have pre-selected just as the stream started, will win a real life, true life telescope of their own. All right, and that's courtesy of Calibos, which is our friend Mike from SpaceX with his girlfriend Tiffany. Calibos is in the chat. It's the first of a number of giveaways that we're hosting. It's going to be a giveaway of binoculars. It's going to be a giveaway of night vision system, the Aurora Sport from Psionics, and a giveaway of a telescope. So it's going to be one of those three things. And down the line, and I think that's something that you guys will appreciate. Okay, 15 exposures here. This is good. And we're good now. So there is the Flaming Star Nebula. Yeah, we're gonna the binoculars and the Aurora Sport are gonna be more sparingly given away. Telescopes are gonna be more common. And again, details you can get from Calibos here in our chats. But to win, you have to be subscribed to SkyTour Livestream. If you're not a subscribed member, and it's free, you know that, then you can't participate, unfortunately. So please do make sure that you are subscribed. That's the most important thing. Okay. All right, we got 18. We're going to save those now, and then we're going to be done with this guy. Nice. Beautiful flaming star. And how would it appear to your eye if you look through a telescope? Well, it might look like what you're about to see. Which is that. You might not see the subtle nebula is there. You can actually see the brighter part. You can see that bright red part up there. That shows a little bit. Interesting, huh? Yes, tea with honey will help. Thanks, Dean. I agree with you. Oh, look at that wind. Just in time. Okay. Actually, I used to work with some Chinese friends. And they swore by, and I agreed, that the best thing to use was simply hot water with honey. And it was true. Francis Palmer. Yeah, I'm not a drinker. A good shot of whiskey would probably get me the dog like this, you know. Okay. So we have a number of things here to check out. What I'd like to do, though, before we do any of that potentially, is I want to go look for one other thing, which is right in the region that we're looking in. Let's go. I think
There was Capella and the kids.
you're right. I was passing through there for a moment. I was looking for this guy. Here we are. Okay, we're going to check out the California Nebula. You can see the California Nebula right there, very faintly. Alright, what I'll do is I'll bring us down a little bit. And then we'll head to the west a little bit. Okay, and then come up. A little more. Okay. Head this way a little bit. Okay.
There's supposedly a lot of fake honey out there nowadays.
Really?
Oh, so they say. I don't
Fake
know how
honey.
stores could sell this stuff, you know, if they have to, you know, stand behind their product.
Yeah, I don't know how they could sell fake honey. I don't know how that works. But I guess it must. Okay, here we go. Let's see here. This will be a 23-second shot. And we're gonna drop out of this low light mode and go into our stack. Get rid of the last one. This is up on the server right now, so you can go check it out. Look at the beautiful blues in there. Very intricate detail down in here. That's all visible. That was invisible, not invisible, but the details in that beautiful blue nebula were invisible to us with the past camera that we used. Okay, there's the California Nebula, the beginnings of it anyway. But we have to adjust. All right, we're going to adjust. Okay. So we're going to move this up here. No. Okay, there we go. Keep going. All right, a little more. Yeah, that should be good.
The term fake honey is used to describe small amounts of real honey that have been mixed with various other less expensive sugars and syrups.
Okay. Good night, Izabela. Izabela has to head out.
Good night, Izabela.
Great to see you. Thank you for coming. All right, we just gotta do this. Okay, I think this will be good right here. Okay, we wait 11 seconds to get our guide star. You can see up there it says searching right there. Remember, this is our telescope control. This is our telescope computer. Telescope's in the observatory right here. Main window and camera control cluster over here. And me right here. Okay. So now that we're guiding on this, we're going to do another 23-second shot here. All right. And we'll go into our live stack here and get out of that. Now we've moved all this up here.
It is claimed that factories in China are making more fake honey than the entire bee population of the world.
Wow. There we go. That's beautiful. The California Nebula is extensive. It's a large diffuse nebula that's illuminated by a star just out of the field below called Menkib, which is a hot, I believe it's an O-type star. And
Yes.
it's ionizing this hydrogen gas that happens to be in this region, causing it to glow. That's Menkib for you. Yeah, we are. Vincent Giglio says, you get what the wind decides you get. That's right. You're absolutely right. See that if we bring in too much blue, nebula vanishes. But if we actually process it properly, okay. All right. Christine Anderson, what language is that? I was gonna say, again, just off the top of my head, I was wondering if it was Swedish. Okay, let's see if we can. Irish, okay. Okay.
Yeah, I was going to say it looks like Irish.
Yeah, when I saw the league, I wasn't sure how to say it, but oh yeah, that's pretty.
At least it's not Welsh.
What if someone's Welsh?
Well, you'd know it if they were Welsh. Great big long words with a whole lot of L's in them.
Oh, okay. That's very cool. All right, so if you notice, in this nebula, again, this hydrogen cloud, again, we look in the galaxy, you're not going to find an area that is devoid of these amazing red clouds, followed by black dust knots and lanes. You got some here, here, here. There's one right here that's coming in right here. There's more of this red out here, but you can't really see. It's a little faint right now, but it's coming in. So we turn off the sharpening. You see the natural you see the natural look. You can see this right here. There's a dark blob in here, a dark blob here. Knots of darkness in here. Not a void in the stars. This is a void because you see stars through it. But this, you don't see stars through it. And that's not the only criteria. You can actually tell that there's something here with instrumentation. So if we zoom in on this now. Okay, and we sharpen it up. Look at that. Now let's see if we can reduce the noise a little bit. Interesting. Fascinating, isn't it? Moving our way through this nebula. This is live in real time, guys. The universe live in real time. Not bad. We managed to grab 11 of these, and only 2 were rejected. So we have a lot of green tonight on this. So this means the wind might be abating. So now, let's see. We're going to change this to California Nebula. And then we'll save it. Color correction. And then save exactly as seen. Okay. There we go. Not bad, not bad. So there's our California Nebula. Now, in a similar vein, there's another stellar nursery that would be fun to check out. It looks really pretty. So we're going to go check that out too. And we've got to basically come back down here. We're going to come in here now. And we're going to go right here. All right. Now we're going to feature part of a nebula. and it's called the Tadpoles. Remember the Tadpoles, Daryl?
Yes. I'm not thinking of something else.
I don't think you are. Okay, so what I'm going to do, that's the letter Y cluster right there. So the tadpoles are up here. So we're going to, when we get control back, we're going to go up there. All right. All right. We're going to head up this way. And then we're going to head to the east. And put this cluster down in the lower right. Why would I do that? Because what we want to see is up here. All right. I don't think you're thinking of something else, Daryl. Okay, this should showcase.
Got to see it first.
Yeah. Cosmic Ray has added some interesting insights into this object. Okay, we're gonna we'll do a 25-second shot here. A little wind right there, but that's okay. We have our filter on, so we'll be able to find it. Okay, and then this is the California. That's just really pretty. Alright. Now, we should be able to see the tadpoles. Might take a couple exposures to bring them in. Of course, we have to make sure we get within our... So I'm going to come up just high enough to maybe catch it for this full width half maximum diameter. And 1 second. And here we go. Okay. I went too high. Because they're right here. Okay, no problem. We'll go back and move those in the center so you can see the whole nebula. So we'll put this right there. So we're going to go south a little bit. And then we're going to go west. Okay, there we are. And we'll go through the obligatory 11 to 14 seconds to catch our star. We got a lot of stars to guide on, so it'll be quicker, and it is. Okay, so we're guiding now. And again, let's do our 25-second. All right. So what we've done is we move this cluster here up here. So that's good. And we're looking at the tadpoles, which is a little feature that's right here, as you'll see. And we're going to take off this over processing. All right, look at that. So this will be So the tadpoles are right here. And these will come in very nicely. We've got 2 in already. Dark Nebula in here. Again, this is a stellar nursery powered by hot young stars. And this stellar nursery is also host to these 2 strange fishtail looking objects, the tadpoles. Let's color correct this. That's better. Now we zoom in a little more so you can make it more clear what we're looking at. There's a tadpole, there's a tadpole. And more really convoluted dark nebula down here. Excuse me.
I caught a tadpole when I was a kid.
That out of the way.
I took it home and put it in a big fish bowl, a deep one, so he couldn't get out. And
Yeah.
I went out and watched it. It was sitting out in the garage. I went out and watched it every day, and you could see when he started sprouting legs,
Yeah.
and he still had the tail.
Yep.
And then one day the tail was gone, and he was gone right after that. He jumped out of the fish bowl.
You can't hold back life, man.
Yeah.
Okay, let's enjoy this. Let's move this out of the way, and let's watch this come in. Wow, look at that.
Life finds a way, as Jeff Goldblum said in Jurassic Park.
That's right. This is pretty. So you can see those beautiful filamentary nebulous appendages here. These are actually potentially caused by the hot young stars that are causing the nebula to glow, because they have a copious amount of radiation that they're giving off in the ultraviolet, and this could be forcing material back, and there might be a very dense head up here and the stuff trails behind. It's a possibility this is what we might call a pillar in some other instances.
I find I see several star lines in there, like we do sometimes, and they're curved.
Yep.
Almost wonder if those aren't real, somehow formed inside the nebula. I mean, it could just be a superposition, but sometimes it makes me wonder.
It is interesting. Wow. You can see some detail now in this dark nebula area here. Again, this is dark dust that's up here obscuring what's behind. Okay, that's how that's actually working. And the brighter red could be a denser gas. So more, as I mentioned before, more hydrogen atoms per cubic centimeter that are being ionized for like a few light years. So that's pretty dense there, relatively speaking. But still, it's not dense enough so that if you were in the middle of it, you'd even see it. If you were in this cloud, right in the middle of this, say right in the middle of here, you might not even notice the red around you, because once you're within it, then it's everywhere else but where you are. It's like when you're in the fog. No matter how thick the fog is, it always looks like the fog is blocking the end of the field that you're standing in. But as soon as you get to the end of the field, you can see the end of the field and all around you. But where you just came from is now blocked by the fog. It's a matter of how many particles are between you and there. Remember, folks, tonight we have a telescope contest running. If you want a telescope, guess of a number between 1 and 1,000. We're hosting this telescope contest courtesy of Calibos and Tiffany. And we're giving away a telescope, and at other points we may give away binoculars and the Aurora Psionics, the Psionics Aurora Sport. I have one. This is all good stuff. Can we have 12 stacked images? Huh? Well, you know, that'll be up to Calibos. And I gotta tell you guys, this is not gonna be just some baby telescope, 3 inches long and a little toy. No. Calibos, if you have the specs, do you want to put them up? Tell them what they're getting. Hey there, James Hyatt. James Hyatt's entered his number. He says $5.99. Hey there, Fantasy. How you doing, man? Look at that. Here's our tadpoles right here. Now, in case you're wondering what it is we're talking about, we're looking at that guy there and this guy here.
They really stand up now.
Yeah, these two together make up the tadpoles. This is the letter Y cluster, and it's actually a cluster made of these hot young stars that in part is responsible for the glow of this nebula, and probably mostly responsible for these tendrils we're seeing here. Cosmic Ray, what you could do is you could promote us to all your friends that you know. then maybe this would become the thing that you're complaining it's not. Francis Palmer, it's early over there, yeah. Just after 5 for you. Well, we managed to get 20 out of this. So let's bring our telescope back to view here. Here we go. Let's redock this right here. And we got to change this name here to the Tadpoles.
Nice picture.
Yeah. Stars are a little bit elongated, but
Yeah.
that's okay. I have it. If you notice where I have my number, it's at 8.8 instead of 6.2. If I had dropped this down to like 6.91 or 6.9, we would have had maybe 10 frames. But they'd be perfectly round stars. See, we got one for 6.7. All right. Well, there we go. All right. Well, that's about it for us tonight. I think that we're gonna call it tonight. Now, for those that want to do their last minute entering of a number, now's your chance. And if you enter more than once, only the first number you mention will be taken. But to be eligible, you have to be a subscriber to SkyTour Livestream. So please do subscribe. And that said, we're happy to host this contest courtesy of Calabos and Tiffany, our good friends. So if you're going to put in your last numbers, do it now. Because when the stream ends, that's it. Whoever's left over, we will be getting your information if we find a winner in our chat tonight, which I do believe we may. Renee Cruz says 666. That's interesting.
Calabos asks if
I want to announce the winner.
Yeah.
That might work.
Thought you were going to try the Orion Nebula before you left.
It's not high enough yet.
Mm.
Yeah, I'll check it.
He says it's in
that's
Facebook
true.
chat.
Yep, I'm looking at it right now. Okay. Just a minute, folks. Getting final confirmations. James Hyatt, sorry about the clouds. Okay. I want to let you know that We are no longer taking guesses. We have a winner. We have a winner. And I'd like to announce that. So, as of now, I want to let everybody know that the person who was closest to the magic number tonight was, drumroll please, JSCO 77. You win a brand new Celestron Star Sense telescope. How about that? Excellent. Holy cow. Well done, man. Well done. And there's more to come. Now, the number was 693. And you guessed, what did you guess? You guessed, I can't figure what you I wasn't calculating how far away you were. Let me see how that was. Yeah, you said 700. You were 7 away from 693. So you win. Congratulations. Now, what you need to do is contact me. Go to skytourlive.org and contact me directly and give me your contact information, and we will send you your telescope. Okay, courtesy of Calibos and Skytour Livestream. So I'm telling you, we're serious. We're not kidding about this stuff. Darn straight you're blown away. You just won a telescope, brother. Now it'll fit on your desk. It's tiny. It's about 3 inches. No, just kidding. It's actually a full-size telescope. You're going to love it. Terrell says, ho, ho, ho. Merry Christmas, JSCO. You've earned it. You've been, like many of you here, you've been a faithful watcher. And so I know that many of you will also be winners in the coming months as well. All right. So let me know, JSCO, in the Skytour live stream, skytourlive.org. Send me your contact info, okay? All right, folks. We are going to call it for the night before my voice goes completely out. But I wanted to just share with you that I had a great time spending this night with you. And I think you did too, Daryl. Alicia's funny. Yeah, JSCO, you won a new scope. Yeah, the mouthwash. A bottle of mouthwash. And no. Dean Bosador, thank you. That's very kind of you. Giving congratulations to JSCO. Well, thank you guys. Thanks to all who participated. And again, as this contest grows, I imagine there's going to be a lot more people in the future. So this was really, really cool. So you guys have a good night. And I'm sure we'll talk again in the coming few days or so. I'll keep you guys posted. And again, we have a new scope to put it out there. And we'll be getting that done. We got another site to look at, do another site survey very soon to look for a dark sky. So I'll talk to you guys and spend the time with you the next stream. Daryl, thanks for coming on and spending the time with us.
Oh, sure. Have a good night,
All right.
everybody. If we don't see you before then, Merry Christmas to everyone. Happy Hanukkah. Happy holidays.
Happy holidays to everybody. And we will talk to you very soon. See you all. And once again, lastly, congratulations to JSCO 77. Happy holidays from all of us at Skytour Livestream and from Calibos and Tiffany, who made this all possible for you guys tonight. So thank you guys, and we'll catch you on the flip-flop. JSCO, you can dream of your new telescope. We'll get you all the details as soon as you get us our information that we need. Thank you guys, and good night.
Good night, everybody.